Dear students, here now let us discuss about an important result that depends upon open sphere. Actually, what is an open sphere? Open sphere means that XD be a metric space, means X is a vector space together with a specified metric D. Then let X0 and R are positive. Then the open sphere with the center X0 and radius R is denoted as SR X0. SR X0 is known as open sphere. The open sphere having center X0 and radius R is denoted by SR X0 and is defined as SR X0 equals set of all X of all in X with dx X0 strictly less than R. dx X0 strictly less than R. So this SR X0 is always a part of X. This is a subset of X. Why? Because X of all in X with the dx X0 strictly less than R. SR X0 is also non-empty. Why? Because it is always non-empty. Why? Because X0 fall in SR X0. Agree? So this is an open sphere. So open sphere is defined as, or it is denoted as SR X0 and is defined as SR X0 equals set of all X of all in X with the distance between X and X0 strictly less than R, or dx X0. What is d actually? D be the specified metric which is defined on X. Okay. Now, by using this open sphere, we define an important method, that is open set. It's an important term, open set. What is an open set? So, for let XD be a metric space, then G be a subset of X. This G is said to be an open set if there exists an open sphere SRX which is a part of G. G is a subset of X. G is said to be open in X. G is an open set in X if there exists an open sphere SRX which is a part of G. That means G is the union of this SRX for all X of all in X. If G is the union of SRX for all X of all in X, then G is said to be an open set in X. Okay, so this is the open sphere and the open set. Clear? So now let us discuss an important result that is depends upon this open sphere and open set. So the result states that in any metric space X, each open sphere is an open set. Each open sphere is an open set. Each open sphere is an open set. How? So to prove this one, each open sphere is an open set. How to prove this one? So for each open sphere is an open set. Let SR X0 is an open sphere. SR X0 be an open sphere. Now to show this SR X0 is an open set. How? To prove SR X0 is an open set, let X fall in SR X0. X fall in SR X0. By definition of SR X0, that means distance between X and X0 strictly less than R. Okay, by the definition of SR X0. Put up R1. R1 equals R minus dx X0. Since dx X0 less than R, surely R minus dx X0 is strictly positive. Means R1 is positive. Clear? Now, to show SRX0 is an open set, we have to show that this SRX0 has an open sphere. Why? Why? Because of the definition of open set. G is an open set when there exists an open sphere SRX such that SRX is a part of G. That's our definition. G is an open set when SRX is a part of G. Agree? So, to show SRX0 is an open set, it is enough to show that there exists an open sphere which is a part of SRX0. So, let R1 is positive. Now to show that this SR1X is a part of G, part of SRX0. Okay. So for letter Y falling SR1X. Now we have to show that this Y fall in SRX0. Y fall in SR1X means what is the distance between Y and X or X and Y? That is strictly less than sum R1. Distance between Y and X or distance between X and Y strictly less than R1. Now let dyx0. Dyx0 equals, what is dyx0? Dyx0 which is less than or equals dyx plus dxx0 by the triangle inequality. Triangle inequality of the metric. So dyx0 less than or equals dyx plus dxx0. What is dyx which is strictly less than r1 plus what is dxx0 or r1 plus dxx0. From here, what is r1 plus dxx0? That is nothing but r. So, which equals r. That means dyx0 strictly less than r. Dyx0 strictly less than r means y fall in SRx0. Okay, by definition. But y is chosen from where? SR1x. Y is from SR1x. The same y fall in where? SRx0. So, we may conclude that this SR1x is a part of SRx0. So, finished. Why? Since SR1x is a part of SRx0, means SRx0 has an open sphere. That means SRx0 is an open set. So, every open sphere is an open set. That's an important result. The proof is in this way. Clear? Now consider another result. So the result says that let X be a metric space with a metric D. Then any two distinct points of X can be separated by open spheres. X D be a metric space. X D be a metric space. Consider X and Y are any two distinct points. So X and Y are any 2 points. Suppose here it is X and it is Y. Then these 2 points, these 2 distinct points are separated by open spheres. That's our aim. X and Y are any 2 distinct points or any 2 distinct points in a metric space together with a specified metric is separated by an open sphere. How? Suppose X and Y are, let X and Y are any 2 distinct points in XD. X and Y are any 2 distinct points. Since X and Y are distinct points means what about the distance? Distance between X and Y should be positive. Strictly the dxy differs from 0. That means dxy is strictly positive. Let r equals, since dxy is positive, let r equals dxy by 2. Since dxy is positive, r is positive. X and y are any 2 distinct points. X and y are distinct points means, so what about SRx intersection SRy? Surely there is which is empty. SRX intersection SRY is empty. Why? Suppose they are non-empty. So let us Z fall in SRX intersection SRY. That means distance between Z and X, or Z fall in SRX and Z fall in SRY, that is positive. Then finally there is a contradiction to the fact that X differs from Y. So clearly SRX intersection SRY is empty. SRX intersection SRY is empty means SRX and SRY are two disjoint open spheres. That is, these 2 points are separated by these 2 open spheres. So the result is immediate. Okay. Now let us discuss an important result. The complement of a singleton set is open. Complement of a singleton set means let X be a metric space. The result says that let X be a metric space. Singleton set X. X singleton set X means it consists of only one point. We have to show that the complement of singleton set X, that is X complement or X dash, singleton set X dash is open. Complement is open means the singleton set is closed. Okay. So how to prove the singleton set is closed? We have to show that its complement is open. Okay. How to prove this X dash is open? X dash is a complement of the singleton set X. So what is actually singleton set X dash? Singleton set X dash is nothing but X minus singleton set X. Okay, that's the complement of singleton set X. X dash is X minus singleton set X. So to show this X dash is open, we have to show that this X minus singleton set X has an open sphere. Okay, right. So to show singleton set X is open, we have to show that X minus singleton set is X is open. So for let Y fall in X minus singleton set X. Y fall in this one means immediately Y differs from this small x. Y differs from x. Okay, Y differs from x. Y differs from x means what about the distance? Distance between x and y should be positive. Okay. Put R equals. Put R equals dxy by 2. R equals dxy by 2. Now, to show X minus singleton set is X is open, now we have to show that some SRX is a part of X minus singleton set X. This is our requirement.